Chapter 1, looking at section 1.1, graphs and graphing utilities. A lot of what we're going to look at in this lesson are topics that you've already done, you already know, but there are a couple pieces in there to make sure that we've covered all the bases. So we are going to look at plotting points in the rectangular coordinate system, graphing equations in the rectangular coordinate system, interpret information about a graphing utilities viewing rectangle or table. That's kind of a key point that you may not be as familiar with. We are going to use a graph to determine intercepts and interpret information given by graphs. So as I said, a lot of stuff that you should already know. The rectangular coordinate system, it says that we draw a horizontal and a vertical line that intersect at right angles. The horizontal line is your x-axis, the vertical line is your y-axis. The point of intersection for these axes is their 0 points known as the origin. That's at that point 0, 0 right in the middle of your graph. It says positive numbers are shown to the right of the origin and above the origin. Negative numbers are shown to the left of the origin and below the origin. You should all be familiar with that by now. Plotting points in the rectangular coordinate plane. It says each point in the rectangular coordinate system corresponds to an ordered pair of real numbers. It's x and then y. It says the first number in each pair, called the x-coordinate, denotes the distance and direction from the origin along the x-axis. The second number in each pair, called the y-coordinate, denotes the vertical distance and direction from the origin along the y-axis. So, plotting a couple points, as I said, you know this. If you had to plot the point -2, 4, we know we have x values and y values. So along the x-axis, we go to -2, and then we're going to go up to +4, and that would be that ordered pair -2, 4. If we were plotting the ordered pair 4, -2, along the x-axis we're going +4 spaces, and along the y-axis we'll go down 2. So I'd go over to +4 and down -2, and have the ordered pair 4, -2. If you don't know how to plot points by now, I don't know how you got to PreCalc. Graphs of equations. It says that a relationship between two quantities can be expressed as an equation in two variables, such as y is equal to 4 minus x squared. It says a solution of an equation in two variables, x and y, is an ordered pair of real numbers with the following property. When the x-coordinate is substituted for x and the y-coordinate is substituted for y in the equation, we obtain a true statement. Now, some things we're going to graph. You may remember some kind of little tricks or whatever else that you would have learned Algebra 1, Algebra 2. But when in doubt, you could always go back to making a table of values, plugging in some points, and finding what you'd end up with on your graph. Graphing utilities, the graphing calculator is also helpful as well. So in general, if you don't know what it looks like, take and plug some numbers in and see what your graph gives you. So for example, we have graphing y is equal to the absolute value of x plus 1. And so we have kind of an extended table with the work in the middle column. So if we go and plug in our x value of -4 for our x value, -4 plus 1 is going to give us -3. Absolute value of -3 would give us a +3. We'd have that ordered pair, input -4, output +3. Then we would plug in a -3. -3 plus 1 is a -2. Absolute value gives us that +2. So we have our ordered pair -3, 2. We plug in -2. We end up with a +1. We plug in a -1. We end up with a 0. We plug in a 0. We end up 0 plus 1 is 1. Absolute value gives us 1. We plug in 1. 1 plus 1 is 2. Absolute value is 2. And we plug in 2. 2 plus 1 is 3. Absolute value is 3. So we end up with a bunch of ordered pairs that we could then go and graph. So when we're at -4, +3. We're at -3, +2, -2, 1. -1 left and right, up and down 0. A lot of people mess up the 0. Always make sure you're taking first number left and right, second number up and down. So then we have 0 left and right, we're up at +1. Over at 1, we're up at +2. And over at 2, we're up at 3. And this makes a nice V-shaped graph. Hopefully you remember absolute value makes a V shape. Absolute value, 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 V, right? Nice easy way to kind of remember that. When in doubt, make a table, plug some numbers in, and see what you get. All right, so graphing utilities. This says graphing calculators and graphing software packages for computers are referred to as graphing utilities or graphers. To graph an equation in X and Y using a graphing utility, enter the equation and specify the size of the viewing rectangle. It says the size of the viewing rectangle sets minimum and maximum values for both the X and Y axis. So it says, for instance, the negative 10, 10, 1 by negative 10, 10, 1 viewing rectangle is called the standard viewing rectangle. Now, what does that mean? It says, what is the meaning of in this case, it has a negative 100, 150 by negative 100, 110. So in terms of our window, if we are going to have a negative 100 by 100, that is going to refer to our X values. That means we are going from a negative 100 to a 100. So on our X axis, we are going to go from a negative 100 to a positive 100. And this 50 here means that every little tick mark that we have, these 50, means that every little marking that I would have in between there would represent 50 spaces. If I have this other 100 by negative 100 to 100, that's going to talk about my Y value. That's going from a minimum of a negative 100 to a positive 100. And this one says we have a 10 and we have a Y scale of 10. That means it's going to have 10 tick marks. I can't quite count 10, but it's going to have 10 tick marks in between here to show that every little space that you're counting is counting by tens. So it says the minimum X value is, we'd have, as we said, that negative 100. The maximum X value is a positive 100. And then the distance between consecutive tick marks on the X axis, we said was going to be that 50. Then the minimum Y value we said was a negative 100. The maximum Y value was a positive 100. But as we're counting our tick marks, we're counting by tens. So anytime you look at a graphing calculator, you typed in an equation, you hit enter. Every time you're counting those little tick marks, that's what this is referring to. What is our least number? What is our greatest number along the x-axis? What is it counting by? What is our least number? What is our greatest number on the y-axis? And what is it counting by? All right, so one way that you have graphed in the past is by finding intercepts. It says that an x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. The y-coordinate corresponding to an x-intercept is always 0. So when we are finding an x-intercept, that means that our y value is going to be a 0. So if I'm looking at an ordered pair, an x-intercept, I'm going to have a number, comma, 0. If I'm finding a y-intercept of a graph, it's the y-coordinate of a point where the graph intersects the y-axis. The x-coordinate corresponding to a y-intercept is always 0. So what happens with a y-intercept, that means that we have 0 left and right. We end up on the y-axis at some sort of number. So if we were to identify some intercepts of the graph, identify the x and the y-intercept, it says the graph crosses the x-axis at what ordered pair, and then what would be our intercept. So if we look at our x-axis that's going left and right, we're looking at this ordered pair that is over to the left 3 units. So we're going to have a negative 3, up and down 0. So the x-intercept is negative 3. It says the graph crosses the y-axis at, we find that ordered pair. We are going left and right 0, and we're going up to positive 5, so our y-intercept is 5. Again, some Algebra 1 stuff that you would have already seen. Now, interpreting some information given by graphs. It says divorce rates are considerably higher for couples who marry in their teens. The equation D is equal to 4n plus 5 models the percentage, D, of marriages that end in divorce after n years if the wife is under 18 at the time of marriage. And yes, this does happen. About 10 years ago, or maybe a little bit more, I went with my roommate at the time to visit one of her friends down in North Carolina, and she got married when she was 16. And she was like, why aren't you married? Because I was in my 20s. I was like, I just hadn't found the right person yet. And she was like, oh, well, I've been married for like 10 years now. And I was like, oh, congratulations. So yeah, it does happen, and real life example for you. Sorry if that little story bored you. But anyway. All right. So this tells us to determine the percentage of marriages ending in divorce after 15 years when the wife is under 18 at the time of marriage. So if we're looking at after 15 years, and they tell us in terms of, we go back up, it says after N years, and we had D was the percentage of marriages. So after 15 years, we're just going to go ahead and in place of N, we're plugging in those 15. So the percentage of divorces is equal to 4 times 15 and then plus 5. So we have a 4 times a 15. So that gives us what? We got 60 plus 5. We have D is equal to 65. Now D was the percentage of divorces. So after 15 years, the percentage of divorces, we're looking at a 65% chance of divorce. So let's see what happens on the next slide. It says, in terms of continuing what we had, the percentage of marriages ending in divorce after 15 years when the wife is under 18 at the time of the marriage is, we just said it was going to be 65%. It says the graph of D is equal to 4n plus 5 is shown to the left. We calculated that 65% of marriages, whoa, holy cow. Sorry about that. We calculated that 65% of the marriages would end in divorce after 15 years. How can we check our answer with the graph? So if we are inputting an N value of 15, if we go on our graph to where 15 is, and we kind of take a look up here, and we kind of track it back on over this way, can we see that 65 looks like the point at which that would land on our line? So our answer is the point 15, 65, which is on the graph.